Okay, so now we move on to the next part of our lesson in matrices. We are going to learn how to use matrices to represent linear transformations in three dimensions. Okay, so in F1 you already learned about matrices in two dimensions, right? We learned about something called linear transformations in vector in F1. So in F1, in further PO1, you learned that linear transformations in two dimensions can be represented by 2 by 2 matrices. Do you remember you used to do reflection, rotation by using the 2 by 2 matrix that represented, you could do that. So now in this particular, in F3 matrices, the difference is now we are not working with 2 by 2 matrices. We are working with 3 by 3 matrices. So in this chapter, you will extend this work by representing linear transformations in 3 dimensions. So the new point to which the point x, y, z is moved is called the image of x, y, z. This is already something you know, right? So your object point is x, y, z. You apply a transformation, and what does a transformation do? What's the purpose of using a transformation? A transformation is a rule that will take your object to a new point, to a point called the image. So it moves all the object points to a image point by using a certain rule. Maybe it could be a reflection, it could be a rotation, whatever the rule, it's going to move all the points according to that single rule. Okay, however, now the thing is to identify the matrix representing a particular transformation, we consider the effect of the matrix or the transformation on three simple vectors. If you remember in F1, we consider the effect of transformation on 1, 0, 0, 1. Do you remember? This was what we call as a 2 by 2 identity matrix. And we consider all the transformation with respect to this. So in 3 by 3, what we do is we consider the effect of the transformation on the 3 by 3 identity matrix. So who is it? 1, 0, 0, denoted as I. 0, 1, 0, that's the second column, denoted as J. 0, 0, 1, denoted as K. Do you see this is the 3 by 3 identity matrix? Okay, so basically in this one, we take the effect by looking at what happens to these three coordinates. Okay, so each of them are three coordinates here. Okay. Okay, and then let me show you an example here. Okay, then the best thing is we will go with the example. Now, if you check this one, see, let's read through this first of all. Given any matrix M, look at this. Okay, given any matrix M, can you see if the matrix M is a 3 by 3 matrix? There are how many elements? There are 9 elements here, right? So the matrix M 1, 0, 0 is equal to A, B, G. Okay, what does this mean? 0, 1, 0 is the second column. 0, 0, 1 is the third column. So basically what they're saying is the image of 1, 0, 0 is the first column of M. Basically 1, 0, 0, the original matrix is 1, 0, 0. So the image of the object coordinate is 1, 0, 0. What's the image? The image is ADG. When you apply the transformation M on 1, 0, 0, you get the image coordinate is ADG. For the second, now can you see the second set of coordinates? The second column coordinate is BEH, right? So BEH comes when you transform what? When you transform the second column of your identity matrix, 0, 1, 0. And the third one, 0, 0, 1 is the third column of your identity matrix. The object coordinate, the image coordinate is now CF5. So what I'll do is I'll show you from an example what exactly we mean by this. Okay, how does this work? Okay, let's look at this. For example, now look at this example 14. They say given that T, transformation T, this XYZ, this shows how XYZ is transformed. Look at this. So XYZ, the object coordinates are XYZ. Now look at the image coordinate of XYZ. The image coordinate, the first coordinate is X plus Z. The second coordinate is directly Y. The third coordinate is X plus 2Y plus Z. Okay, so then they are saying you given that T is this, find matrices representing T. How do we find matrices representing T? Look at this. So T, X, Y, Z is given by X plus Z, Y, X plus 2Y plus Z. Now wait with me. Okay, this is quite easy to understand. What do we do? Always consider the effect of the transformation on whom? On the three simple vectors. Who is it? The first one is 1, 0, 0. What does this mean? It means your X value is 1, Y value is 0, Z value is 0. So can't you get this is the object coordinate. Can't you get the respective image coordinate? So what's the respective image coordinate? X plus Z. X is 1, Z is 0. 1 plus 0, which is 1. The next one, y is 0. The next one, x plus 2y plus z, x is 1 plus 2y is 0 plus z is 0. What's the answer? 1, 0, 1. So that's the first image coordinate. Under the matrix, under the transformation T, the first image coordinate is 1, 0, 1. Get the second one also. Who is the second object coordinate? The second column of your identity matrix, 0, 1, 0. What happens when you transform 0, 1, 0? Now x is 0, y is 1, z is 0. So what happens? X plus z is 0 plus 0. Y is directly 1. Next one, x is 0 plus 2 times y is 1 plus z is 0. What's the answer? 0, 1, 2. Are you with me? The third column is 0, 0, 1. Get the effect of this. x0, y0, z1. What happens? X plus z, 0 plus 1. Y is 0. X is 0, 2y is 0, z is 1. What do I get here? 1, 0, 1. So can you see the matrix representing T? So what is the matrix representing T? The matrix representing T is 1, 0, 1, 0, 1, 2, 1, 0, 1. Can you see the 3 by 3 matrix that represents the transformation T is given by this? Okay, is this clear? Okay, and then the next part, this part, you need to remember this as well. So in F1, you also learn, okay, in F1, you also learn, look at this. If the transformation T is represented by the matrix T, so the transformation is given by matrix T and the transformation U is represented by the matrix U, then UT. You remember this, UT represents the combined transformation of T followed by transformation of U. Do you remember this followed by rule? In F1, you learned if you say transformation T followed by U, you remember that you write it in the other way. Now, when you say UT, it means T followed by U. That means the transformation that happens first is written in the right side. The transformation that happens second is written in the left side. Now, this looks UT. It looks like U is first, T second, but no. When you're doing transformations, UT represents T followed by U, which means T happens first, U happens second. Okay, so this is a rule you learn in which book? In the further PO1. In the further PO1 book you learn, right? Okay. So is this part clear to you? So when you say here TU, what does this mean? The vector TU means, the matrix TU means this is the transformation U followed by transformation T. Are you with me? Okay. Okay. So we'll go for the next part then. Okay, so then the next one is in this particular example, before we go to the next part, let me explain to you about this part as well. So in part B, they ask you to find matrix U. How do you find matrix U? The method is quite similar. Again, what do? We apply 1, 0, 0 and get the relevant coordinate 0, 1, 0 and 0, 0, 1. In a similar manner that we got the T matrix, we can get the matrix U. You get what I'm talking about here, right? And then the next part here is find the UT transformation. Now, is that difficult? Now, I think you can see here we found the T matrix and the U matrix also. They have found here in a similar way. You can work on it. So they get the matrix representing U. So the matrix representing UT is where you take the U matrix and multiply with the T matrix. You know how to multiply matrices by now, right? So when you come to the F3 book, I hope that you are quite capable of multiplying and working with matrices. Okay, so then we can get the matrix UT by multiplying U matrix with T matrix. You can either use the calculator as well to get the answer here. And matrix TU is where you multiply T with U. Are you okay with it? Okay. Shall we also look into this example 15? So I will be explaining a little bit of these examples before we go into the exercise so that you have a clear idea of what's going to happen in the question. Look at this. The transformation T, now they use a symbol here. Can you please look at this? This R, can you see real number and there's a power 3 here. What does that mean? So they have given you here the symbol R cube is used to represent 3-dimensional space. Can you see? You read T R cube to R cube as the transformation T transforms points in the 3-dimensional space to points in 3-dimensional space. Do you get what they say here? The original points, the object points are in 3-dimensional space. And the image also is going to be in what? 3-dimensional. That's why you have this symbol. The symbol, this is how it reads. 3D object, 3D image. Is that okay? So the transformation T, which transforms 3-dimensional object coordinates to 3-dimensional image coordinates, is represented by matrix T. The point with question vector 1, 0, 0 is transformed by T to the point with question vector 3, 4, 2. Can you see? The point with question vector 1, 1, 0 is transformed by T to the point with question vector 6, 1, 5. Okay, pay attention. And then they say the point with question vector 2, 1, minus 4 is transformed by T to the point with question vector 1, 1, minus 1. Find T. Okay, how do we find T? So how do we find T? They say, can you remember the technique we use? So now we say here, we let our matrix. Now you're supposed to find the matrix T. So we say let T be. Can you see we use, we build up a 3 by 3 matrix by using these letters A, B, C, D, E, F, G, H, I. Okay, and then what do? How do we find the matrix T? Now they have given you the object coordinate and the image coordinate. Are you with me? They have given you the, now the object coordinate is obviously, you know, the 3 coordinates are 1, 0, 0, 0, 1, 0, and 0, 0, 1, right? These are object coordinate. Now the transformation, do you remember the rule we use in F1? Transformation matrix multiplied by what coordinate? Transformation matrix, when you multiply with the object coordinate, what do we get? We get the image coordinate. Are you with me? Okay, transformation matrix multiplied by object coordinate, image coordinate. So now I have the object coordinate, the very first object coordinate is 1, 0, 0. Now 1, 0, 0 is transformed by T. Okay, T, when you use 1, 0, 0 by T, 1, 0, 0 is transformed to what? 1, 0, 0 is transformed to 3, 4, 2. Are you with me? But have they given you the rule with which they transform? No, the rule is not given to you. That's what you're supposed to find. And by using T, 0, 1, 0 was transformed to what? The point with question vector, this should be 0, 1, 0, right? Sorry, no, they have given you, this is a different rule they have given. Sorry, they have given here the point with question vector 1, 1, 0. Okay, so we'll have to go with the example, right? They say here, it's not, they are giving you a separate set of object coordinates here. Can you see 1, 0, 0, 1, 1, 0. They are giving you a separate set of coordinates here for the object coordinate, and they are giving you the respective image coordinate. 1, 1, 0 is transformed by T to 6, 1, 5. Are you with me? Okay, and then the next one, by using the transformation, the point with question vector 2, 1, minus 4 is transformed to 1, 1, minus 1. So what are we supposed to do? We are supposed to find the value, we are supposed to find the matrix T. So you need to realize first of all in here, for a 3D coordinate to transform to a 3D image coordinate, your T matrix, your transformation matrix has to be a 3 by 3 matrix. So that's why they say here, let T be, can you see A, B, C, D, E, F, G, H, I? The 3 by 3 matrix. Okay, so then what do? We use this equation, we use the rule. Transformation matrix, when you multiply with the object coordinate, you get what? You get the image coordinate. So can you see what they do here? The transformation matrix is A, B, C, D, E, F, G, H, I. First we will go with the first coordinate. Who is the first object coordinate? 1, 0, 0. When you multiply, you get the image coordinate 3, 4, 2. Are you with me? Okay, shall we multiply this? Are you aware of the method of multiplication? The first matrix is a 3 by 3, 3 rows, 3 columns. This matrix, there are 3 rows and how many columns? 1 column. What happens when you multiply a 3 by 3 matrix with a 3 by 1 matrix? The result is a 3 by 1, right? The result you get it from the 2 corner values. 3 by 3 with 3 by 1 is, so the resulting matrix is 3 by 1. 3 by 1 means what? You have what? How many rows? You have 3 rows and only 1 column. 3 rows and 1 column. So how did we get the rows? The rows are provided by the first matrix. The rows are provided by the first matrix. Columns are provided by the second matrix. Isn't it? Shall we multiply? So A into 1 is A. Plus B into 0 is 0. Plus C into 0 is 0. Can you see? The multiplication. Do you get what I'm doing here? You multiply row 1 with column 1 to get the first element. Do you remember the matrix multiplication? A multiplied by 1 plus B multiplied by 0 plus C multiplied by 0 is the first row, first column, the first element. The second element, second row, first column, right? Because you know that you are supposed to get 3 rows, row 1, row 2, row 3. For 3 by 1 means 3 rows and 1 column. So rows are provided by the first matrix, columns are provided by the second matrix in matrix multiplication. You learn this in F1. The second row, the second element, how do we get? We get D into 1, that is D, plus E into 0 is 0, plus F into 0 is 0. The last element, G into 1 is G, plus H into 0 is 0, plus I into 0 is 0. Can you understand? And you get here 3, 4, 2. Now, what do you get here? You just got the values of A, D, and G. A, D, G is equal to 3, 4, 2. Do you get what's happening here? So you get here A equals to 3, D equals to 4, and G equals to 2. Okay, do you get what's going on here? Can you similarly now, without looking at the example, can you all see whether you can get the answer for the second, apply the rule for the second coordinate as well? The second object coordinate and image coordinates are given to you. Can you apply that? Okay, so then to get the remaining elements, what we do now is, again, you apply the transformation. Okay. A, B, C. So actually now we know the A, B, G values, right? So you can replace your A with 3, B, C, D is 4, E, F, G is 2. Okay, I think you might have seen now if you check the first element, the first matrix, the first object and image coordinate, did you notice that the transformation matrix was immediately the image coordinate? That happened because of what? Because the first element that we transformed was the first column of your identity matrix. Do you think that's going to happen with the second one? No, why? Because the second object that we are moving is not a column of the identity matrix. It's 1, 1, 0. If it was 1, 0, 1, 0, then you can you should realize if this is 0, 1, 0, your BEH will be 615. Do you get what I'm saying? If this was 0, 1, 0, then your BEH value will be 615. But since it's not, you'll have to definitely manually work with it. Okay? Okay, so now as this is not a column of the identity matrix, the object coordinate is something else. So because of that, we will definitely have to manually work with it. This is 110 equals to 615. Okay, so then again you need to open the bracket. So I think I'll just refer the example. So let's look at this. Do you want me to open it? So look what they have done here. Now we use the ADG as 342 and then they multiply. So you get here 3 plus B plus C into 0. That's basically 3 plus B is 6. You get it, right? And then 4 plus 1E plus F into 0. So that is 4 plus E is equal to 1. Did you get it? 2 into 1 plus H into 1 plus I into 0. So you get 2 plus H is equal to 5. You understand the matrix multiplication, right? You multiply the first row with the first column. The second row with the first column. The third row with the first column. That's what we do. And then basically we can easily get the BEH value. So B value is 3 plus B is equal to 6, which means B equals 3. 4 plus E equals 1, which means E equals to 1 minus 4, which is minus 3. 2 plus H equals 5, which gives you H equals 5 minus 2 is 3. Is this clear? Okay, and then the last element also we will have to manually work with it because now I think the last one is going to be a little bit more tough. Can you see? Because you have 2, 1, minus 4. None of the coordinates are having a 0 in it. That means you have to fully multiply. But I think it's easy because you now know 6 of the elements in your transformation matrix. You can find the last column very easily. Do you get what I'm talking here? A, B, C, A, D, G, and B, E, H values are found. The first 2 columns are found. So in your transformation matrix, the first 6 columns can be replaced. Only C, F, and I are unknown. Are you with me? So transformation matrix into object coordinate. The last one is 2, 1, minus 4. This is transformed to what? 2, 1, minus 4. The image coordinate is 1, 1, minus 1. Are you with me? So again, the first row with the first column, 3 times 2, 6, plus 3 times 1, 3, plus C into minus 4 is minus 4C, 9 minus 4C. Are you okay with this? 4 into 2 is 8, plus minus 3 into 1 is minus 3, plus f into minus 4 is minus 4f. So then you get 5 minus 4f for the second one. The third row is 2 into 2, 4, plus 3 into 1, 3, plus I into minus 1 is minus 4y, and you get the 7 minus 4y equals to 1, 1 minus 1, and you again solve three equations separately, get the CFI values. Is this clear? Okay, do you understand this example? Okay, and then they ask you to find the image of the point with question vector minus 1, 3, 0. How do you find the image of this point with this question vector minus 1, 3, 0? So is it difficult to find it now? In part B, can you all find the image of the point with question vector minus 1, 3, 0? What should we do? Transformation matrix into the object coordinate is minus 1, 3, 0. So you're supposed to find the image coordinate. Find it. Transformation matrix T is what? 3, 4, 2, 3 minus 3, 3. What was CFI? CFI is 2, 1, 2, right? Into minus 1, 3, 0. Can't you multiply this and get the answer? 3 by 3 with 3 by 1. So get the answer here. The first row multiplied with the first column. 3 into minus 1 is minus 3, plus 3 into 3 is 9, plus 2 into 0 is 0. That's the first element. 4 into minus 1 minus 4, plus minus 3 into 3 is minus 9, plus 1 into 0 is 0. Next one, 2 into minus 1 is minus 2, plus 3 into 3 is 9, plus 2 into 0 is 0. So what's the image coordinate? Minus 3 plus 9 is 6, minus 4 minus 9 is minus 13, minus 2 plus 9 is 7. So this is the image coordinate. Is this clear? Okay, look at the next example. So I'll be explaining you the examples first, and then I'll take you to the questions. Okay. Now look, the transformation T, again, the object coordinate from 3 dimension is moved to the image coordinate in 3 dimension, is represented by the matrix T. Now the matrix is given to you. Can you see? The matrix is given to you. The line 1 is transformed by T to line 2. Okay, now in the earlier example, what were we moving? We were just moving single coordinates, right? Single object coordinate to single image coordinate. Now we are actually using this transformation T to what? To actually move an object line to an image line. Are you with me? The line L1 has vector equation R 2, 0, minus 3 plus P 3 minus 2, 1. I think all of you are now quite familiar with this format. What is this format? R equal A plus PB. A is the position vector on the line. B is the direction vector on the line, right? So this is your object line. What are they asking you to do? They are asking you to find the image line. How do we find this? So basically what you do here is, now you know R represents, can't we get the general coordinate of any point on the line? How do we get the general coordinate of any point on the line? Can you add it? 2 plus 3t. Next one, 0 minus 2t. Next one, minus 3 plus t. Are you with me? Okay, so this is basically the position of the coordinates for any point, any general point on the line. So basically, you treat this as a coordinate. This is your XYZ coordinate. And what do? We apply transformation matrix into object coordinate gives the image coordinate. Do you agree with me? Transformation matrix is 3, 1, 2, minus 2, 3, minus 1, 1, 4, 1. Along multiply with the image coordinate, the object coordinate. The x coordinate is 2 plus 3t, y coordinate is minus 2t, z coordinate is minus 3 plus t. Are you with me? Shall we multiply? So you know, this is entirely one column, okay? Are you with me? This is entirely one column. So there are 3 rows, row 1, row 2, row 3. And there's only one column here. Are you with me? So when you multiply, this is a 3 by 3 matrix along with a 3 by 1 matrix. So your answer is a 3 by 1 matrix. So when you get a 3 by 1 matrix, shall we multiply? 3 times 2 plus 3t. And then you have to add with minus 2 times minus 2t. And 1 times minus 3 plus t. Are you with me? I multiply the first element with the first column. Row 1 element with the column 1 elements. Are you with me? The second one is 1 times 2 plus 3t plus 3 times minus 2t plus 4 times minus 3 plus. This is the second element. The second element in the 3 by 1 matrix. The next one, 2 times 2 plus 3t minus 1 times minus 2t plus 1 times minus 3 plus t. Are you with me? Let's open the bracket. 3 times 2 is 6, 3 times 3, 90, minus 2 into minus 2t is plus 40, 1 into minus 3 is minus 3, 1 into t is plus t. The next element, 1 into 2 is 2, plus 1 into 3t is 3t, plus 3 into minus 2 is minus 60, 4 into minus 3 is minus 12, 4 into t is 40. Next one, 2 into 2 is 4, 2 into 3 is 60, minus 1 into minus 2t is plus 2t, 1 into minus 3 is minus 3, 1 into t is plus t. Are you with me? What do we get here? 6 minus 3 is 3. Can you add the t terms? 90, 40, 1t is how much? 14t. The next one, 2 and minus 12 is minus 10. 3t minus 60 plus 40 is how much? Add it. How much? Plus 1t. Next one, 4 minus 3 is 1. 60, 2t, 1t, 90. So this is the image. Now you know you are getting the image coordinate, right? This is the image coordinate. A transformation matrix into object is the image coordinate. Are you following me? Can you break it up now? 3 minus 10, 1 along with the other one has t. Break it. Take t out 14, 1 and 9. So actually who is this? This is your image coordinate. Image coordinate or I broke up the image coordinate to get the equation of the line. This is the image line. So this is how we transform the object line into a what line? Into the image line. Can you see? The method is quite similar. How we transform the object coordinate to image coordinate. Basically, you take your line as a coordinate and then multiply it with the transformation matrix. At the end of this, separate the numbers and the parameters. And then you get the R equal A plus PB format. Is this clear? Okay, so question number 4 is quite similar to the example that we discussed earlier. So they say here the transformation T represented by matrix T is given to you. The line L1 is transformed to line 2. The line L1 has vector equation R equal to 241 plus T times minus 1 minus 2, 3, where T is the real parameter. Find the vector equation of line 2. Okay, basically the method is exactly the same, right? We add the position vector and direction vector and get the coordinate of the line, isn't it? And then we use the equation transformation matrix into object coordinate equals image coordinate. The transformation matrix is what they have provided over here. The object coordinate is the object coordinate of your line. And we added the 2 plus minus t, 4 minus 2t, 1 plus 3t. So we take these two and we multiply, right? So it's a 3 by 3 matrix multiplied with a 3 by 1, which means your answer matrix should be a 3 by 1 matrix. Are you with me? Yeah, can you all tell me the answer you got after you multiplied? So this is 0 times 2 minus 3 is 0, minus 1 times 4 minus 2t. Shall I immediately multiply? Minus 1 into 4 is minus 4, minus 1 into plus minus 2t is plus 2t. Next one, 2 times 1 plus 3t is plus 2 plus 6t. Is that okay? Check on this and let me know. The next one, 2 times 2 minus 3 is 4 minus 2t. Next one, 5 times 4 minus 2t is 5 times 4, 20. 5 times 2 is 10t. Minus 4 into 1 plus 3t is minus 4. Minus 4. Minus 4 into plus 3 is minus 12t. Next one, 3 into 2 minus 3 is 6 minus 3t plus 8 minus 4t plus 1 times means 1 plus 3t. Can I have the simplest answer here? Minus 2 plus 8t, 20 minus 24t, 15 minus. So when you separate the image coordinate, the straight line becomes minus 2, 20, 15 plus t times 8 minus 24 minus 4. Is this okay? And then they say to you, now what if in the exam they ask you give your vector equation in the form R minus A cross B? So is it difficult for us to give the answer in this format? So you know A is going to be the question vector, B is going to be the direction vector. Just put those two values for A, B and you get your answer. Okay, is that okay? Because they do ask stuff like this. Let's move on to the seventh question. The transformation T moving from three-dimensional object to three-dimensional image. Okay, is represented by the matrix T. Okay, again T is given by this 3 by 3 matrix. The plane 1 is transformed by T to plane 2. Now this time what are we moving? We are moving planes. Plane 1 is transformed to plane 2. The plane 1 has vector equation. Again, you can see now in the plane, you know, we defined by this is definitely a coordinate on the plane, right? You remember R equal A plus, you know, these two with the parameters are two direction vectors on your plane. Do you remember vectors? These are the two direction vectors on the plane. This is a question vector on the plane. Okay. So let's apply. Can you all get me the coordinate of a general point on the plane? Can you add everything? 0 plus S plus 3t. 1 minus S plus 0 into t is 0. 1 plus 2S plus 4t. Are you with me? Shall we separate? So this is our coordinate. Let me write it again. S plus 3t. 1 minus S. 1 plus 2S plus 4t. So this is your object coordinate. So how do we get the image coordinate? Transformation matrix multiplied by the object coordinate. Are you with me? So this is a 3 by 3 matrix. This is a 3 by 1 matrix. So let's multiply. What do we get here? 4S plus 12t plus 5 minus 5S. Basically, I'm multiplying this with this, right? 4 times S plus 3t, that is 4S plus 12t. 5 times 1 minus this is 5 minus 5S. Minus 3 into 1 plus 2S plus 4t. Minus 3 minus 6S. You can understand if I write this at once? Okay, everyone, because it would save us a lot of time because we will otherwise waste an extraordinary amount of time. Next one. Minus 1 is multiplied by S plus 3t, which gives you what? Minus S minus 3t, that is with minus 1 and S plus 3. Next one, the 2 with 1 minus S, so plus 2 minus 2S, right? And the last one, 1 times, you multiply 1 with 1 plus 2S plus 4t, so there's no difference. Agree? The last element again, 1 times S plus 3t, no change, right? S plus 3t. 0, when you multiply anyone with 0, it's going to give you entirely 0. And the last one, 1 times 1 plus 2S plus 4t is the exact same thing. Can you understand the multiplication? Can you all give me the simplified answer here? 2, how much? Minus 7S. The t is cancelling out, right? Yeah, and then the next one, 3 minus S plus t. And the next one, 1 plus 2S, yeah, plus S is 3S plus 7t. And now it's time to separate. So separate the three, this is the image coordinate, separate the normal numbers, the t variable and the S variable. So you get here 2, 3, 1 plus S times minus 7 minus 1 plus 3 and t times on top there's no t means 0t, 1t, 7t. So this is the equation of the plane, the transform plane. However, the question says you to find the equation of plane 2 in the form r dot n equals b. So r dot n, now you know here, this 2, 3, 1 is a question vector on the plane. Remember vectors? These two are direction vectors on the plane. How do we now r dot n equal p? N represents what? N represents a vector who is perpendicular to the plane. And here p is supposed to be what? Who is p? Can you remember? The proper format of r dot n. R dot n equals, who is p? A dot n. A dot n. This is the exact format. You need to remember the vectors lesson. R dot n equal A dot n. Okay. So basically what you do here is you multiply, now you need to get the n value first because A is a position vector on the plane. I know A is 2, 3, 1. How do we get an n is the vector who is perpendicular to the plane. Now I already have two direction vectors on the plane, right? -7, -1, 3, 0, 1, 7. These are two direction vectors on the plane. You know what the cross product gives in vectors? We learned the cross product of two vectors gives you what? A vector who is perpendicular to both the original vectors. So basically get the cross product. How do you get the cross product? You remember it's the determinant of a 3 by 3 matrix, right? The first one, -7, -1, 3. The next one, 0, 1, 7. Okay, can we get the, can you all get the n vector? Plus I times -1, 1, 3, 7. Minus j times -7, 0, 3, 7. Plus k times -7, 0, -1, 1. Are you with me? -7, -3, minus j times -7 into 7 is -49, -0, plus k times -7 into 1 is -1, -z. So n equals, what is it? -10, 9, -49 into minus is plus 49j, -7k. Are you with me? This is your n. Okay, so we are ready now to apply to the answer here. R dot n equal A dot n. So R dot n is -10, 49, -7. How do we get A dot n? A is a position vector on the plane. Who is what? 2, 3, 1. Dot n is -10, 49, -1. So you know how to get the dot product. Can you all get the dot product here? R dot -10, 49, -7. 2 into -10 is -20. 3 times 49 is 1 times -7 is -7. How much is it? Equals to 120. Okay, is this clear? So you could write your answer as R dot -10i 49j -7k equals 120. Is this clear? Okay, so next, before I go to the next part, there's one more thing I wanted to learn about. That's when they give you, now you saw in the previous example that we were discussing in this question, they gave you the equation of the plane in the vector form, right? Can you see? They gave you the transformation matrix and they gave you the plane in this manner, right? So they gave you the plane in vector form. But now look at this example, example 18. In example 18, can you see? Listen to this very carefully. In example 18, they say T is the matrix is given. The transformation matrix T is given, which moves object coordinates in 3D to image coordinates in 3D. Okay, but now they are saying the plane has equation 2x minus y plus 3z equal -6. Now they have given you the plane in what form? They have given you the equation of the plane in Cartesian form. In the question we did in the exercise, the plane equation was given in vector form. In vector form, when they give it to you, it's very easy to get it into a coordinate x, y, z and multiply. But in here, do you see that we don't have it in that manner now? Can you see the problem we run into? Okay, so then they're asking me to find the image of the plane under this transformation. Okay, how do we find the image of the plane? Now the thing is, we need to what? We need to have the equation of the plane in a coordinate form, right? Because we need to multiply transformation matrix with the object coordinate and get the image coordinate. Are you with me? And now, you know, when it comes to a plane, okay, so what I was saying to you was that in a plane is represented normally by how many parameters? 2 parameters. Straight line has 1 parameter. You need to listen to this very carefully. Okay, the words that I'm saying will be really helpful to you in the exam. Okay, so a plane we normally denote it with, we write the equation, now we saw in the vector form also, there were two parameters, isn't it? So when they give you the plane equation in this manner, now you can see they have it's the Cartesian form of the equation. So what you need to do here is, okay, we are going to take two parameters here. Like we are going to manually introduce two parameters here. Okay, so now when you have 2x minus y plus 3z equal minus 6, can you see in the example what they have done? This is really important. They test this in the exam. Okay. Okay. So they say here let x be equal to s. So that we are going to take the x coordinate as one parameter. And z be equal to, actually if you want, you could take y be equal to e as well. Okay. Just take two coordinates, x, y or x, z or y, z, any two, and make each variable equal to one parameter. And then the third variable, you will write in terms of those two parameters. Now, I think you can see here the reason why they went for x and z. Why? Because in this equation, it's very easy to make y the subject. Can you see? When you make y the subject, it's quite easy because y is having a coefficient of 1. Are you with me? So they used x as s and z as t, the two parameters. And then can't you write y in terms of s and t? We can. Are you with me? And then what we do is, then we use those three values to write the general coordinate on the plane. So x, y, z coordinate, right? So x coordinate is s. Y coordinate, can you see how they have got 6 plus 2s plus 3d? How have they got 6 plus 2s plus 3d? They replaced the x here with s and y, z here with t. And took the minus y to the other side and took the minus 6 to this side. Can you see what I'm talking about? So this is the x coordinate, the y coordinate, the z coordinate. Can you see how we have got the general coordinate on the plane? Okay, the way we manufacture the coordinate on the plane, this is the way we manufacture. When they give you the plane in the Cartesian form. Are you with me? And then what do we do? And then what we do is we use this coordinate to multiply with what? To multiply with the transformation matrix multiplied by the object coordinate. Can you get started on this? Multiply the transformation matrix with this object coordinate, get the image coordinate. Can I know the multiplication answer here? 2 into s is 2s, right? Minus 1 into 6 plus 2s plus 3d is how much? Minus 6 minus 2s minus 3d. The final one plus 3 into t is plus 3t, right? Okay, the next coordinate, can you all multiply? Minus 1 with s is minus s. Then 4 times 6s plus 2s plus 3d is 24 plus 8s plus 12t. And the next one, minus 2 into t is minus 2t. Do you understand the multiplication? The next one, 3 times s is 3s. And the next, you multiply 2 times, 6 plus 2s plus 3t, which is 12, 4s plus 6t. And the last one, 4 times t. Can you all separate this out? Can you all add and everything? What do we get here? Minus 6. Only minus 6, right? And then 24 plus 7s plus 10t. And the next one, 12 plus 7s, 3s plus 4s is 7s plus 10t. So this is the what? This is the image coordinate. Are you with me? Okay, so after you get, now you know this is the x, the image x coordinate, image y coordinate, image z coordinate. However, the thing is, the original equation was given to you. Was it given to you in terms of s and t? No, the original equation of the plane was given in Cartesian form. So it was given in terms of x, y, z. So you must also give your final answer in terms of x, y, z. S and t must be removed because we input s and t as we like, right? Do you remember we used x as s and z as t in the way that it was easy for us to simplify. Okay. So because of that, s and t were not a part of the original form. So it should not be a part of your answer. So how do we remove it? You can take here x is equal to minus 6 and the next one y equals to 24 plus 7s plus 10t. How do I get rid of the s and t? I think you can see we can take a pair of simultaneous equations. Y minus 24 equals 7s plus 10t. The next one, z equal 12 plus 7s plus 10t. I think both of these equations are having 7s plus 10t, right? Shall I subtract the two equations? Equation number 2 and 3, I think if we subtract, we can get rid of the s and t, right? Yeah, 2 minus 3, y minus z equals, can you tell me, 24 plus 7s plus 10t, you will subtract it, 12 plus 7s plus 10t. What happens? You get here y minus z equals 24. Are you with me? Y minus is 24 minus 12, which is 12. The 7s cancels out, the 10t cancels out. Is that okay? Okay, so look at the explanation they have given in the example. They say x equal minus 6 and y minus z equal 12. Please look at this. Are both planes? Can you see? Now we got two answers here. Pay attention. X equal minus 6. Now do you see I got some kind of Cartesian things here, but am I getting it like directly as a plane now? Can you see I got x equal minus 6 separately and y minus z equal 12 separately? Like I'm not getting everything together. Okay, basically what it means now, they say here x equal minus 6 and y minus z equal 12 are both planes. Okay, and the image of the plane is the intersection of these two planes. Now the thing is basically what we now they say here in general under linear transformations points are transformed to points. We saw that. We took a point, it transformed to a single point. Line, when you transform, we expect to see again a line, right? You take a point, transform, it becomes a line. And when it comes to planes also, we generally think what? Plane, when we transform, we get a what? We get another plane, right? Planes depends. However, in this particular example, that's not the case. Okay, in this example, that's not the case. Why? Now, we were originally transforming a plane, right? The plane under this singular matrix, this matrix here is a singular matrix. Okay, so you can see the determinant should be 0. That's why they say here, when the matrix represents the transformation is singular, they say what? The plane is actually transforming not to a plane, but it's coming to a line. Okay, can you all see the way they actually get the Cartesian equation of the line? Now they say here, what is the line? The line is the intersection of the two planes x equal minus 6 and y minus z equal 12. So how do we get them together? Now they say here, the Cartesian equation of the image is x equal minus 6 and y equal z plus 12. Are you okay with that? Please take a look at this. And then what we do here is we say y equals z plus 12 is equal to lambda. Do you remember this lambda from the Cartesian equation of the straight line? X minus x1 over L, y minus y1 over m, z minus z1 over n equals lambda. Can you remember how this lambda came up? So then what we do here is we say, you need to remember these steps here. Y equals z plus 12 is equal to lambda. They take it as lambda. We make y equal to lambda. Okay, you make y equals to lambda. So z plus 12 will also be equal to lambda. Then as x equal minus 6, you can get x plus 6. And we can say x plus 6 is equal to what? 0 times, because x plus 6 is equal to 0, right? So it's equal to, they say 0 times lambda. And what we do here is, now you know x minus x1 over L, y minus y1 over m, z minus z1 over n is equal, supposed to be equal to lambda, right? So x minus x1, who is x minus x1? X minus, you can see we take the minus 6 here as plus 6. So this x minus x1 over L. Now you can see the x plus 6 is equal to 0 lambda, which means x plus 6 over 0 is equal to lambda. Are you getting what I'm saying here? X plus 6 over 0 is equal to lambda. And when it comes to y, we directly have y equal lambda, which means what? This should be y minus 0 over 1, right? Y minus 0 over 1 because it's just y. Are you listening to this? Y minus 0 over 1. And then what about z? Z plus 12 is equal to lambda, right? If z plus 12 is equal to lambda, it means it's z plus 12 over 1. Z plus 12 over 1 because I need it in this format to get the Cartesian equation. So this is the equation of the Cartesian line. The plane is transformed into a line. Okay, but generally this is not the case. Most of the time, you should get a plane becoming what? Another plane. Normally planes go into another plane. Now let's go into the actual question in the textbook. So if you go to the question in the textbook, either you will find that is the case in the textbook. Shall we try question number 6? Try question number 6 and see what happens. They have given you the transformation matrix along with the Cartesian equation of the plane. Can you all again use? Now again, what is the best way to use here? Who are you going to use as S and who are you going to use as T? Because you have introduced two parameters in this. Which one do you use as S and which one do you use as T? You can use any one. X can be S or Y can be S or Z. Just name any two, which is convenient. Look at this. Yeah, it's better if we go, now you can see here 2Y is there. X and Z are free, right? Yeah, so either if you use X as S and Y as T, then Z can be written in terms of X and T. Is that okay? So in this case, it's X is S and Z is T will not, it's going to be a difficult because if you make Y as option, you will get a division by 2. Okay, so it doesn't matter if you want, you can go ahead with it. So in this case, we'll use X is equal to S and Y is equal to T. Okay, shall we start? Okay, so we'll go to question number 6 here. Now you saw here, I told you to use X as S and Y as T, right? And then we wrote the equation here. When X is equal to S and Y is equal to T, we get Z equals to minus X plus 2Y. Minus X plus 2Y means minus S plus 2T, right? So X, Y, Z coordinates are written. Transformation matrix into object coordinates shall be multiplied. Can you all tell me the answer here? 3S multiply minus 2T minus 2 into S is plus 2S minus 2 into plus 2T is minus 4T. Are you with me? The other one minus 2 into S is minus 2S minus 8 into T is minus 8T, and the last one 4 times minus S plus 2T is minus 4S plus 8T. The next one minus 2 into S is minus 2S. 4 into T is 4T, and the other one is directly 0. Do you agree? Can you all tell me the simplified answer here, please? 5S minus 60. Next one. Minus 6S minus 2S plus 4T. So this is what we get here. This is our image coordinate. X, Y, Z image coordinate. Okay, now the thing is, you know, the original question was given in the Cartesian form in terms of X, Y, Z. So your answer, final answer also should be given in terms of X, Y, and Z. Okay, so we cannot give in terms of S and T because S and T are what we input here. It was not a part of the original sum. Do you get what I'm saying? So what we'll do is let's write the equations and then get rid of the S and T. X is equal to 5S minus 60, equation number 1. Y is equal to minus 6x. I think you can see here that I have a good substitution for S now. Can you see? And Z is equal to minus 2S plus 40. Okay, how do we get rid of the, shall we first get rid of the S? Okay, how do I get rid of the S here? Shall I take the first equation? All right, get rid of T first. Wait, Z is equal to what? Minus 2S plus 40. I'll write right over here. Okay, what do you want to get rid of first? Okay, you can get rid of T first or S first. Basically, if I get rid of S first, I just have to multiply this equation by a 3, right? That gives me 3Z minus 6S plus 12T. Okay, and we get here Y is equal to minus 6S, right? So can you see that minus 6S can directly be substituted from here to here? So 3Z equal minus 6S is Y plus 12T. So I get 3Z minus Y equals to 12T. Do you agree? 3Z minus Y over 12 over 12. So now I combine the first equation and the last one. The only one I didn't use is the middle one. So let's use the middle one. X equals 5S minus 60. Shall we substitute? X equals, who is 5S? 5 times, let's replace S value. Who is S value? S is Y over minus 6. S is Y over minus 6, right? And then minus 6 times, who is T? We just found out T is 3Z minus Y over 12. So this is how it generally works. The plane is transformed to a plane. So this gives us, now you can see I have completely eliminated S and T. I have an equation in terms of only Z, X and Y. Okay, so the equation, let's simplify. X equals minus 5y over 6. This one, 6 and 12, we can simplify, right? I get minus 3z minus y over 2. Do you agree? This equation, I'll multiply everyone with what? 6. Do you agree with that I should multiply everyone with 6? Then I get here 6x equals minus 5y over 6 into 6 is minus 5y. This one, 2 times 3. So I get 3 times 3z minus y. Do you agree? So I get 6x equals minus 5y minus 9z plus 3y. Take everything to one side. 6x plus 5y plus 9z minus 3y equals 0, right? Simplified 6x plus 2y plus 9z equals 0. Can you see? So this is it. This is how it typically works. Plane transforms to plane. So when it's given in terms of Cartesian, your final answer also must be given in terms of the Cartesian form. Is this clear?